Pigs outperform dogs and 3-year-old children in cognitive tests. They can play video games using modified joysticks, recognize themselves in mirrors, and remember individual faces for years. They're among the most intelligent domesticated animals on Earth. Yet, in America, 129 million pigs are processed annually. That's 353,000 every single day. One every 0.24 seconds. We imprison people who abuse dogs. We give awards to farmers who efficiently process pigs. The only difference, cultural categorization. We decided dogs are companions and pigs are food. The pig didn't get to vote on that distinction. What you're about to learn will change how you see bacon, pork chops, and the $26 billion industry behind them. If this resonates with you, hit subscribe and share this video. What you're about to see matters. In natural conditions, a sow gives birth to a litter of 10 to 14 piglets after a gestation period of 114 days. She would spend days before farrowing, building a nest from branches, leaves, and grasser behavior driven by hormones that prepare her for motherhood. The piglets would nurse for 12 to 16 weeks, learning social hierarchies, foraging techniques, and communication within the family group. Modern industrial breeding has changed that biological blueprint entirely. Today's sows have been selectively bred to produce litters of 12 to 14 piglets, sometimes more. Their bodies are production units, engineered for maximum output. In the 1990s, average litter size was 9 piglets. Through genetic selection focusing on prolificacy, that number has increased by nearly 40% in 3 decades. But larger litters create a biological problem. Piglets are born smaller, weaker, more vulnerable. Sows physically cannot provide adequate nursing positions for 14 piglets when they possess only 12 to 14 functional teats. The result is intense competition. Once the smallest piglets often fail to secure nursing access and die within the first 72 hours. Industry data shows pre-weaning mortality rates of 12 to 18%. That's roughly 2 piglets dying per litter before they're weaned. In industrial facilities, farrowing happens in crates. These are metal enclosures roughly 60 centimeters wide and 2 meters long. The sow cannot turn around, cannot build a nest, cannot express any of the maternal behaviors her hormones compel her to perform. She can only stand, lie down, and nurse through the bars. The industry rationale is piglet safety. Free-moving sows can accidentally crush piglets, a real risk given that sows weigh 200 to 300 kilograms. Farrowing crates prevent that. But research published in Applied Animal Behavior Science found that well-designed free-movement systems show comparable or lower piglet mortality when sows have adequate space and nesting materials. The crate solves one problem while creating others, but it does so in ways that maximize space efficiency and labor reduction, which is why it remains standard. Picture this: a sentient, intelligent animal, her body flooded with nesting hormones, confined in a space where she cannot take a single step in any direction. For the 5 weeks of nursing, then pregnant again, then back to the farrowing crate. The cycle repeats 2 to 3 times annually until her body can no longer sustain the reproductive output, typically after 3 to 5 years. Then she's cold. Piglets nurse for 3 to 4 weeks in industrial systems, 1/4 the natural duration. At 2 to 5 days old, they undergo a series of procedures, typically without anesthetic. Tails are docked using clippers or hot irons. The industry calls this tail docking. It's amputation. The purpose isn't the piglet's welfare, it's to prevent tail biting that occurs later in barren, stressful housing conditions. Rather than address the environmental cause of tail biting, the industry removes the tail. Male piglets are castrated, usually by physically cutting open the scrotum and removing the testicles. The reason is preventing boar taint, an off-flavor in meat from intact males. Alternative methods exist: immunocastration using vaccines, but physical castration costs less and remains standard practice in the US. Studies measuring cortisol levels and behavioral responses confirm these procedures cause pain. The piglets vocalize intensely during and after the procedures, but anesthetic adds cost and requires veterinary oversight, making it economically prohibitive at scale. At 3 to 4 weeks, piglets are weaned abruptly. In nature, weaning is gradual, taking weeks. Here, it's instantaneous separation. The piglets are moved to nursery buildings. The sow is re-inseminated within days and returns to gestation. For the next 6 to 8 weeks, weaned piglets live in nursery pens groups of 20 to 30 animals in temperature-controlled buildings. They're fed specialized diets designed for rapid growth. The goal is reaching 60 to 70 kilograms as quickly as possible. Then they move to finishing barns. Finishing facilities hold hundreds to thousands of pigs in concrete floored pens. Picture a warehouse, dim lighting, slatted floors, automated feeding systems. The pens provide roughly 0.6 to 0.8 square meters per pig. That's a space smaller than a standard door lying flat. Pigs are intelligent, curious, social animals. In natural or enriched environments, they spend 75% of waking hours exploring, rooting in soil, playing, establishing social bonds. Their snouts contain more sensory receptors than human hands. They're built for investigating complex environments. Here, there's nothing to investigate. Concrete floors, metal bars, other pigs. Nothing to root, nothing to manipulate, nothing to explore. This creates what animal behaviorists call behavioral poverty, an environment so devoid of stimulation that animals cannot express innate behaviors. Research documents the consequences. Pigs in barren environments develop stereotypically repetitive, purposeless behaviors indicating psychological distress. Bar biting, where pigs chew metal bars for hours. Sham chewing, where they make chewing motions with nothing in their mouths. These behaviors serve no function. They're displacement activities, the neurological system trying to cope with chronic understimulation. The air inside finishing barns carries a sharp, ammonia-heavy smell that burns your throat even as a visitor. Workers wear respirators, but the pigs live in it constantly. That ammonia comes from urine accumulating in the pits below slatted floors. Concentrations frequently exceed 25 parts per million, the level that causes eye and respiratory irritation in humans. For pigs spending 4 to 6 months in these conditions, it means chronic exposure to respiratory irritants without relief. Walk past a finishing barn and you might see pigs lying quietly, but that immobility isn't rest. For many animals, it's what happens when movement becomes difficult or painful due to underlying health conditions. From the exterior, these operations appear orderly metal buildings, automated systems, biosecurity protocols. What veterinary research reveals tells a different story. Industry health data, peer-reviewed studies, and USDA inspection reports document conditions affecting substantial percentages of pigs throughout the production system. Joint problems are pervasive. Concrete, slatted floors, necessary for waste management in high-density housing, create chronic stress on leg joints and hooves. Pigs evolved to walk on soil that gives slightly with each step, absorbing impact. Concrete doesn't give. Every step transmits full force directly into joints. Veterinary surveys find that 15 to 25% of finishing pigs show clinical lameness, altered gait, reluctance to move, visible joint swelling. But subclinical conditions, joint inflammation, not yet causing obvious lameness, affect far more animals. Post-slaughter examinations of leg joints consistently reveal arthritis and cartilage damage in 40 to 60% of pigs from industrial systems. Imagine walking on hard concrete for months without cushioning, your body weight increasing weekly due to accelerated growth. No opportunity to rest on soft ground. The condition progresses with each passing week. Treatment requires anti-inflammatory medication and rest, both economically impractical in systems designed for throughput efficiency. Pregnant sows in gestation systems face a different challenge. In the US, roughly 83% of breeding sows spend their 16-week pregnancies in gestation crates, individual metal stalls, 60 centimeters wide. The sow cannot turn around. She cannot walk. She can only stand or lie on slatted concrete. This confinement creates progressive skeletal deterioration. Studies using radiography and post-mortem examinations document shoulder lesions in 30 to 60% of crated sows, hip abnormalities in 40%, and pressure sores from lying on hard surfaces. The body breaks down systematically with each pregnancy cycle. Weight increases. Pregnant sows gain 40 to 60 kilograms, but space remains constant. Research published in the Journal of Animal Science tracked sows through multiple pregnancy cycles. Joint problems worsened with parity. First pregnancy showed minimal issues, but by the fourth and fifth pregnancies, severe mobility problems became common. By the time sows are cold, many can barely walk. Porcine reproductive and respiratory syndrome, known by its acronym PRRS, a viral disease that thrives in high-density confinement. The virus causes respiratory inflammation and reproductive failure. While acute outbreaks can kill 10 to 15% of affected pigs, most survive infection but retain chronic breathing difficulties. Affected pigs show labored respiration. Their flanks heave with effort. They breathe open-mouthed. The lung damage doesn't heal. These animals spend their remaining 3 to 6 months before slaughter with compromised respiratory function. Each breath requires more effort than it should. Research measuring blood oxygen saturation in PRRS recovered. PIGS shows levels 5 to 8% lower than healthy animals, a clinically significant reduction in oxygen delivery to tissues. The disease persists because industrial systems create ideal transmission conditions. When thousands of pigs share enclosed airspace, when stress suppresses immune function, when genetic diversity is minimal due to breeding programs selecting for growth traits over disease, resistance, viruses spread efficiently. PRRS costs the US pork industry $664 million annually in losses. Despite that economic impact, the disease remains endemic because the housing systems that enable it are economically necessary for large-scale production. These conditions, chronic joint deterioration, systematic skeletal breakdown, endemic respiratory disease, represent baseline normal in industrial pig production. This is the state of animals before transport even begins. Veterinary science documents it. Economic structure explains it. What looks like tolerance is often silent suffering. Pigs have limited vocalization in response to chronic pain. Evolution taught prey animals to hide vulnerability. But physiological markers tell the truth. Elevated cortisol, altered heart rate variability, inflammatory. The biological signatures of prolonged distress are measurable and documented. When pigs reach market weight, 125 to 135 kilograms, typically at 5 to 6 months old, they're loaded onto transport trucks. Loading happens through chutes and ramps. Workers use electric prods and sorting boards to move animals who may have never walked more than a few meters in their lives. Many pigs, particularly breeding sows, whose joints have deteriorated through years of confinement, struggle with the physical demands of loading. Transport duration varies based on geography. The average is 6 to 8 hours, but trips can extend to 24 hours or more. Federal regulations require rest, water, and feed every 28 hours of transport. That means a 27-hour journey requires no stops. Enforcement is limited. The USDA's Animal and Plant Health Inspection Service has fewer than 200 inspectors covering all livestock transport nationwide. Inside the trailers, pigs experience temperature extremes. Metal trailers become ovens. In summer heat, internal temperatures can exceed 40 degrees Celsius. In winter, Wind chill through slatted sides creates hypothermic conditions. Pigs have minimal ability to thermoregulate. Compared to humans, they can't sweat, and their options for behavioral temperature control are eliminated by crowding. Research published in the Journal of Animal Science instrumented transport trailers with temperature and humidity sensors. Summer transport showed core body temperatures rising to dangerous levels, 39.5 to 45 degrees Celsius, compared to normal of 38.5 degrees. Winter transport showed rectal temperatures dropping to 36 degrees. Clinical hypothermia. Animals in the center of the trailer experience crush injuries from crowding. Those on the outer edges face maximum temperature exposure. Transport mortality. Pigs dying en route or shortly after arrival averages 0.4 to 0.5% of animals shipped. That sounds minimal until you scale it. With 129 million pigs transported annually in the US, that's 516,000 to 645,000 animals dying in transit or immediately after. The primary causes documented in industry mortality reports: heat stress, trauma from trampling, heart failure in animals whose cardiovascular systems cannot handle transport stress. But focusing on mortality misses the larger picture. The animals who survive arrive at slaughter facilities in a compromised physiological state. Studies measuring blood, biomarkers, cortisol, creatine, kinase, lactatio transport create severe metabolic stress even in animals who appear physically intact. Their immune systems are suppressed. Their muscle tissue shows microscopic damage. They arrive depleted before slaughter even begins. At slaughter facilities processing 10,000 to 20,000 pigs per day, animals move through a standardized sequence. After unloading, pigs are held in pens for several hours called larage time. Then they're moved single file through chutes toward the stunning area. The most common stunning method in US pork slaughter is carbon dioxide gas chambers. Pigs are loaded into gondolized metal cages holding 8 to 10 animals, which descend into a pit filled with concentrated CO2. The gas causes unconsciousness through anoxy-oxygen deprivation to the brain, but the process isn't instantaneous. Research using video analysis and physiological monitoring shows pigs remain conscious for 15 to 30 seconds after entering the gas. During that time, CO2, which is acidic when it contacts moist membranes, causes burning sensations in the eyes, nose, throat, and lungs. The animals show distress behaviors, gasping, escape attempts, vocalizations, then they lose consciousness. Industry audits and scientific studies document that this method causes distress before unconsciousness. The American Veterinary Medical Association, in its guidelines on euthanasia, acknowledges that CO2 causes pain and distress, but accepts its use in commercial slaughter due to throughput requirements and worker safety considerations. Alternative methods exist: electrical stunning, nitrogen hypoxia, but CO2 remains standard in US pork production. After stunning, pigs are shackled by a hind leg and hoisted onto the processing line. A worker makes an incision, severing the major blood vessels of the neck. Death occurs through exsanguination, bleeding out. The process is designed to occur while the animal is unconscious, but stunning failures happen. Research conducted at commercial slaughter facilities using EEG monitoring to verify unconsciousness found that 3 to 5% of pigs showed brain activity indicating potential consciousness during shackling and bleeding. For those animals, consciousness may persist into the final moments. The system processes these failures as acceptable losses. In facilities slaughtering 15,000 pigs daily, a 4% stunning failure rate means 600 animals per day potentially experiencing some level of awareness during procedures designed to occur under unconsciousness. Industry responses focus on improving stunning reliability rather than addressing whether the entire system built on maximum speed throughput can ever reliably eliminate suffering at this scale. for an industry generating $26 billion annually in the US alone. Each percentage point shift in consumer behavior represents hundreds of millions in lost revenue. That creates structural incentives for information management. The National Pork Board spends $9.6 million annually on federal lobbying. Compare that to fruit and vegetable growers, who spend approximately $3 million combined. The disparity isn't accidental, it reflects economic priorities. 8 US states have enacted ag-gag laws, legislation criminalizing undercover investigations of agricultural facilities. These laws make it illegal to document conditions inside farms and slaughterhouses without permission. The stated purpose is biosecurity and protection from animal rights extremism. But federal courts have struck down several ag-gag laws as unconstitutional violations of free speech. In 2020, the Ninth Circuit Court of Appeals ruled Idaho's ag-gag law unconstitutional, stating it suppressed speech addressing matters of public concern. The pattern repeats across states. Industries lobby for anti-transparency legislation. Civil liberties organizations challenge them in court. And judges consistently rule that preventing documentation of farming practices violates First Amendment protections. Yet new variations of these laws continue to emerge. Language manipulation operates more subtly. The industry doesn't use gestation crates, it prefers individual housing systems. Not tail docking, but tail management. Not stunning failures, but operational variability. These aren't accidents. They're deliberate framings tested through focus groups and communications research. Research suppression happens through funding strings. In 2017, investigative journalism by The Guardian revealed that agricultural companies had threatened to withdraw funding from universities whose researchers published findings critical of industry practices. Scientists interviewed described pressure to frame results favorably or avoid publishing certain data entirely. This isn't conspiracy theory. These are strategies documented in court records, congressional testimony, and investigative reporting that won Pulitzer Prizes. The question isn't why would they hide this? It's how much does it cost to keep hidden? When profit margins are calculated per animal and throughput per hour, transparency becomes a threat to business models built on consumers not thinking too carefully about production methods. But a pig's journey doesn't end at slaughter. Parts you'd never suspect end up in products you use daily. The heart valves are harvested for human cardiac surgery. Porcine valves are used in over 250,000 heart valve replacement surgeries annually worldwide due to their structural similarity to human valves. The skin becomes medical-grade material for burn treatment grafts. The pancreas is processed for insulin production, though synthetic insulin has largely replaced porcine insulin in human medicine. It's still used in veterinary medicine and in some countries. The intestines are cleaned and processed into sausage casings and surgical sutures. The blood high in protein and iron becomes an ingredient in animal feed and agricultural fertilizers. Gelatin extracted from skin and bones appears in pharmaceutical capsules. Cosmetic face masks, gummy candies, marshmallows, and photographic film. Even the bristles have commercial use. High-quality paintbrushes use boar bristles because of their natural taper and paint-holding capacity. Industrial bone char is used in sugar refining to remove color and impurities, which means even some refined white sugar has passed through pig remains during processing. Look around right now. Within arm's reach, you likely have 3 to 5 items containing pig-derived ingredients or materials. That medication capsule, that gummy vitamin, that bandage adhesive. The animal whose intelligence rivals a dog's becomes dispersed across dozens of products, many bearing no obvious connection to pork. This isn't waste reduction or resourcefulness, it's economic maximization. Every component has a price. The pig becomes a bundle of revenue streams, not a sentient being who experienced a life. So what now? You've just absorbed 14 minutes of information that contradicts marketing images of happy pigs on sunny farms. You might feel overwhelmed, skeptical, defensive, or upset. All normal responses when cognitive dissonance hits this hard. But here's what matters. You're not a hypocrite for having eaten pork. You're human. We're all products of food systems we didn't design, cultural norms we didn't choose, and marketing that deliberately obscures reality. The issue isn't personal guilt, it's systemic design. Change doesn't require perfection. It requires direction. Every meal where you choose plant-based protein over pork is a small economic signal. Multiply that by thousands of people making similar choices, and it becomes market pressure that companies cannot ignore. US pork consumption has already declined by 8% since 2014, while plant-based meat sales grew by 45% in the last 3 years. Consumer behavior drives industry response. Support investigations and transparency. Organizations doing undercover documentation work even when ag laws try to stop them need financial backing and public support. Legislative pressure works. 9 states have banned gestation crates after sustained advocacy campaigns. Progress happens through sustained pressure. If you eat pork, buy from producers who provide verifiable Better Welfare Act or access. No gestation crates, no tail docking without anesthetic. Yes, it costs more. That price difference reflects the true cost that industrial systems externalize onto animals, workers, and the environment. The pigs in this video weren't abstract statistics. They were individuals sentient, intelligent, capable of joy and suffering. The system treats them as production units. You don't have to. Subscribe to this channel. Share this video. The industry spends millions ensuring you never see this information. Every share breaks through that barrier. The animals cannot speak, but you can.